Okay, we've simplified rational expressions. Now let's see what happens when we have more than one together. I want to remind ourselves something real quick. When we multiply fractions, we're multiplying 2 over 3 times 4 over 5. Remember what you'll do. You'll multiply straight across. That would really be 2 times 4 over 3 times 5. And you get 8 over 15. When you're dividing fractions, remember if we had had same problem but division, it would have changed. You actually multiply by the reciprocal. So we'll flip the second one, and then we'll multiply across. So we're going to change that to multiplication, and then we'd have 2 times 5 over 3 times 4, which gives me 10 over 12, which of course can be simplified, and we want to if we can. Divide both sides by 2, and you get 5 over 6. Now that brings up a good point. Simplifying fractions. I'm just going to make a little side note here. When you're simplifying fractions, let's say we have 2x over 5x. When you're simplifying fractions, what you're really doing is dividing the numerator and denominator by the same thing. I can divide the numerator and denominator by x and get 2/5. When you are doing what your teacher may have called canceling out, you're actually dividing. And this works because let's say it had been 3 in for x. 2 times 3 over 5 times 3, 6 over 15, truly does reduce to 2/5. So that's why it works. Now if it had been instead addition, a lot of people try to do the same thing. They try to divide out something that's being added. Now let's take that situation and again plug in a number. Let's go ahead and do 3. 2 plus 3 over 5 plus 3 is 5 over 8, which is not 2/5. So this does not equal 2/5. It is as simplified as it can get. You cannot divide out when it's addition. Okay, so we brought up that little side note. Now I want to look at some problems here. Start with an example, and I will walk you through the step-by-step process with an example. Now, just like when we were simplifying rational functions, our first step is always going to be to factor anything and everything we can. So let's make a little note here. We're going to factor all that we can. So in capital letters, factor. Factor everything. So we look across here. Is there anything they have in common? Well, sure. That's a 4x. And that'd be x minus 1. In the denominator, well, that's an easy one. X times x gives you x squared. Positive 3 and negative 1 multiply to be negative 3 and add to be 2. In the next fraction, we'd have x times x and then positive 3 and negative 2 multiply to be negative 6 and add to be 1. In the denominator, I have 4x. Now, just like in that example earlier, we're going to be multiplying across. Multiply across. And I cannot spell today. So when we multiply across, as we did up here, it becomes one fraction, and you're just multiplying what was in the numerator and multiplying together what's in the denominator. Now, we want to look for common factors that we can divide out. So you're looking for those common factors. Now, every matching pair can get divided out, but we have to be careful. As soon as we divide them out, we need to make a note that that is something that caused a whole. In other words, x cannot be the value that makes those 0. So we notice here we have x minus 1 and x minus 1. Now, we definitely know that there's a whole at 1 because that's the value that makes those 0 over 0. So there would be a note here that x cannot be 1 because it divided out. We have x plus 3 and x plus 3. We have to think about what value would make x plus 3 be 0, and that's negative 3. And if you notice, we also have 4x and 4x are matching. When those divide out, what makes 4 times x equal 0? Well, that's just 0. And let's see what we have left. Looks like all we have left is x minus 2. So that one really did simplify very nicely. Let's look at my next example. I'll do another multiplication and then we'll go on to division. 20x minus 5x squared over x squared minus x times x squared plus 3x minus 4 x squared minus 16 and then times 3x plus 12. Okay, so we have 3 different things here, but we're going to follow the same rules. We're going to factor first. That's the first thing you should always look for is factoring. So we're looking for anything these two have in common. Well, we have a 5x in common. 5x times 4 gives me that, minus x. And then down here that's x times x minus 1. Now, since we're going to end up with all these together, I can go ahead and make one big fraction, actually. Factoring that numerator is x plus 4, x minus 1. X squared minus 16 is a difference of squares. So that's going to be x plus 4, x minus 4. Now, even though this isn't a fraction, we can turn it into a fraction. It'd be that over 1, which times 1 really you don't have to write. But this is times 3 times x plus 4. All right, now we want to look for anything we have in common. What is in common? Well, I have x plus 4 and x plus 4. Now, it's only a pair that can be marked out. Not that one and that one, but only one pair. Can't do that one as well. He has to stay. So I need to mark down that x cannot be negative 4. Look for any other matching pairs. Got x minus 1 and x minus 1. So x cannot be 1. Any more that we can divide out? We have an x here because this is really 5 times x. So I can divide out those x's. And what would make x 0? Well, 0. Now let's see what we have left. Since it's all multiplication, we can combine what we can. Here's 5 times a 3. We can go ahead and put those together. That's a 15. And we have a 4 minus x. Now we talked about before that if we factored out a negative 1, what it's going to do is reverse that. So what if I did that up here? What if I factored out a negative 1? That would make this a negative 5, and it would flip this and turn it into an x minus 4. Oh, that would be really nice because there was an x minus 4 up here, so we missed that originally. If I divide out the x minus 4s, I'm going to put 4 on my list. And this would end up being a negative 15. Let's see what else we have left. We had the 5 times the 3, and we had another x plus 4 there. And now we don't have anything left on bottom. it really did simplify all the way. All right, I have a couple more. We're going to need to do a division problem. So let's look at a division example. Let's take 4x minus 20 over 12x squared plus 12x divided by x squared minus 3x minus 10 over x squared plus x. Now again, your first step should always be to factor. Well, the first one is really easy. I know that's going to be 4, and I'll get x minus 5. And down here, 12x factors out, and that would be an x plus 1. Now what I want to be careful of is noticing that this is division. So I'm going to multiply by the reciprocal. Now you can do it in 2 steps. You could go ahead and factor it, which, you know, I can actually factor it right here. What does that factor into? Well, that would be an x minus 5 and x plus 2. And the denominator, an x could factor out. So that'd be x times x plus 1. Now that's handy, because now I'm going to flip or take the reciprocal of that fraction and get x times x plus 1 over x minus 5 times x plus 2. And now all I have to do is look for my common factors and divide them out. Handy. I've got an x minus 5 and an x minus 5, so I know that x cannot be 5. I've got an x plus 1 and an x plus 1. Well, I didn't need to write that again. Negative 1 would not be allowed. I have an x, and this is actually 12 times x, so I can divide out that x. It means I would need to include 0. See if there's anything else I can simplify or factor out. Oh, I could divide out a 4. Divide that by 4 and I get a 1. Divide that by 4 and I get a 3. So let's see what we have left. There's a 1 still left on top, and 3, and x plus 2. And you're done. Now what if we combined division and multiplication in the same problem? So let's take this next one. I'm going to have x squared plus x over x plus 5 divided by 9x squared minus 25 over x plus 5 times 3x minus 5 divided by, I'm going to just keep adding on here, divided by x squared minus 1 over 3. Okay, I wanted to make this one a little bit challenging as our last one, but it's really easier than it looks. What I want to do is step by step factor anything and everything I can. So we can even do some of this right up here on the problem. I know that these have an x, so x is going to factor out. This looks like the difference of squares. That's going to be 3x plus 5 and 3x minus 5. Difference of squares again. X plus 1, x minus 1. I think we factored everything we can. So now let's rewrite it and see what we have. Here's that numerator. That's x times x plus 1. X plus 5 was in the denominator. We're going to multiply by the reciprocal. So this denominator goes up top. That becomes x plus 5. And the numerator, 3x plus 5, 3x minus 5. Now, 3x minus 5 by itself, that would really be over 1. So that's 3x minus 5 over 1, which I really don't need to write times 1, but I will. And now we're dividing by this fraction. So I need to multiply by the reciprocal, which would be 3 over x plus 1, x minus 1. All right, now the fun begins. We need to look for, let me put parentheses around that too, any common factors, because those get divided out. So let's look. X plus 5, x plus 5. So x cannot be negative 5. 3x minus 5, 3x minus 5. Now you need to be careful there. To figure out what would make those 0, that's 3x equals 5. That's going to be 5/3. Anything else? Ooh, I see an x plus 1 and an x plus 1. So x can also not be negative 1. And right now I'd really like to see what I have left. I have an x times a 3. That's a 3x. In the denominator, I have 3x plus 5 times 1. I really don't need to do times 1. And then I have an x minus 1. Now be careful here. Some people will try to divide out the 3x and the 3x here. Remember, this one has addition. If it's being added, you can't divide it out. So you would be done.